Hello, my name is Adam El Hamdi, and this is my smart home simulator project. What it is basically a console-based C++ application that will let users manage virtual smart devices across their home, mainly lights and thermostats. And so what I'll be doing today is walking you through the class design, showing you my source code, giving a bit of an explanation, and then at the end, I'll demonstrate some functionality so you guys can see exactly how it works. Okay, so the first place I'd like to begin is the class design overview, basically. So I'll start with the device.h class. It's only about 30 lines, as you can see here. And the device class is an abstract class. It's got four protected, member variables or private member variables. Those are device ID, name, location, and is on. And then publicly, it's got some virtual functions. And these are the public ones. They're pure virtual functions. So it has a virtual deconstructor for proper cleanup through base class pointers. Most importantly is the pure vital function called getStatus. That's this one right here. What this does is that it makes device abstract, so that way I can instantiate it directly and I don't have to use derived classes. Next up, okay, next up is smartlight.h. Again, this is only 20 lines, pretty short, but it's my first derived class, and it inherits publicly from device on line 6 right here, as you can see. And it adds a private member, just one, called brightness, which ranges from 0 to 100. This basically allows users to select the brightness of their light. And then I'll move on and show you guys smartlight.cpp. Okay, here we are in smartlights.cpp. It's pretty short. It's only about 50 lines of code, but Smartlight's my first derived. Smartlight is where I use polymorphism. It's one of the places I use polymorphism throughout this project. Over here, I override turn on. Sorry, here. So if brightness is 0 when turning on, then it'll set the default to 100. It automatically sets the brightness to 100 so that the light's actually visible. Otherwise, it might not be, it might not seem like it's working. So the getStatus function here, right here, getStatus const is on. This returns a different string depending on whether the light's on or off. Okay, so next up, we've got smart thermostat, which is similar as well. It inherits from device and adds a target temperature variable. So it also overrides getStatus. Let me show you. It also overrides getStatus here on lines 30 to 37. And it has its own implementation for this. Basically, it just shows how the same function call can behave differently depending on the actual object type. And then now that we've seen all this, I'll show you guys home.h. Okay, so now that we're here in home.h, I'll explain a little bit about it. So home.h is my manager class. Some of the key things here is my vector of device pointers, which is this guy right here, standard vector device, all devices. This is basically where my polymorphism really shines. In this, I can store both smart lights and smart thermostat objects in the same vector and call methods on them through base class pointers. And with that wrapped up, we will move into my source code walkthrough. Okay, here we are in the source code walkthrough. First thing I want to talk about is dynamic memory allocation in home.cpp. So here's my home.cpp file. If we scroll down a little bit, we can see here device pointer, well, let's do this actually. So this is the home class, right? And this is where I use dynamic memory allocation when adding new devices. So when I add a new device, I use the new keyword here, new smart light, to either create a smart light or a smart thermostat. My smart thermostat one is right here, on the heap, and then store the pointer in that vector I showed you before. Yes, so I also have to prevent memory leaks. So I do memory cleanup up here. For device, delete device, all devices.clear. This is so I don't have any critical issues or overflow of my, or not overflow, but so I don't have any issues or memory leaks. So my destructor basically, it loops through all the devices and pointers and calls delete on each one. And without that, my heap memory would be a mess and leak when the home object is destroyed. So then going down a little bit more, I'll show you some polymorphism and how it's used. Okay, so here in control device, I have a smart light pointer. In smart light, I can use dynamic cast, which is this, to determine the actual type of the device. So this lets me show specific menus for specific devices, because smart light and smart thermostat are not the same. One controls for brightness and the other for lights, temperature, controls for thermostats. You know how it is. So this is dynamically casted. And the same thing for the other one. But also, on lines, where is it? Here, this is also dynamically cast. And here, so for status, get status, what's happening here is that's my polymorphism coming into play. What I do is I loop through the device pointers and call get status on every single one of them. And at runtime, what C++ does is it'll correct the overridden version. So smart lights will get the light menu, and smart thermostat will get the thermostat. And then finally, file IO. So file IO, I have a save to, and I have a write. Where's my write to? Oh, sorry, load from and save to. There we go. So load from and save to. That's what I use for persistence. Basically, I save each device type ID. And in that device type ID, it includes things like you have the device type ID, you have the name, location, the on and off state, and the type specific attributes. And I use quotes around them just to handle spaces and device names. It makes it easier to parse. And then here in the load from, what's going on in load from is this is basically just like reversing this process. So what happens is I delete existing files, and then I do that to prevent memory leaks. And then I create an appropriate object with new. So I use that to create a new object, and then I add it to my vector. And then I also track the maximum ID so that new devices can get new IDs, and it's nothing fancy. It just adds 1 every time. So new next device equals max ID plus 1. And with that, I have wrapped up this section, and I'll take you through to the live demo. Okay, so here we are in the live demo. Basically, I'll be giving you a rundown of how this works. It's pretty simple. So all I have to do, first off, is navigate to where my project is located. So it's in my computer science folder, project 2, and smart home. And once I'm there, I just have to, since I've already made it, but I've included a maker file actually, which I learned how to make. So there's a maker file that'll help you run it. So I'll do // smart _ home, and here we go. So first things first, I'll add a smart light. So to add a device, you press 1, enter, and then I want to add a smart light. So I'll press 1, enter, and then I want to name it living room lamp, and for the device room, I want it to be in the living room. Cool. Now I can set my initial brightness. I think I'll go with 75. I don't want it too bright. And next I will add a thermostat. So I'll add another device. For this time, I'll press 2, which is a smart thermostat, and I will call it the bedroom thermostat. Bedroom thermostat. And I'll put it in my bedroom. Same process there. Now I want to put a temperature. I'll go with, it's winter, so I'll do 74. Now to view all my devices, I just have to press 3. And now it's telling me all my devices have been added. So I have 2 devices and their statuses. Now for controlling a device, I'll show you how I can control it. So I'll press 2 to control a device, and then it'll ask me which device I want to control. So I have the first one, that'll be my light, and then I can figure out what I want to do with it. So I think I'm going to turn it on, and then I'll set brightness. And for my new brightness, I'll go with 50. And then now that I've done that, I want to show status of my light. Okay, so it looks like it's on. Brightness 50, and I'm done. So I'll go back to my main menu. Cool. So now let's control the thermostat. It'll be a similar process. So I'll press 2, and then I'll put 2 again for the device ID, which is my thermostat. From here, I want to turn it on, and then I want to, turn it on. I want to set temperature. My new temperature, I want to put it maybe at 71. And now I want to show the status. So here it is. It's set to 71 and it's on. And with that, I'm done. So now let's view my devices by room. So I can actually filter. So I'll do view devices by room. Enter room name. I guess I'll go with my living room. Let's see what's in there. Cool. So I have I have a living room lamp on, and it's at brightness 50. So let's say I want to save this. I will do save configuration, which is 5, and then I'll enter a name for it. I'll call it new config.txt. Cool. So now that that's saved, I'll load it to prove that it works. So what I'll do is I'll create a dummy light, enter name dummy light, location dummy, and I'll set it to 50 because why not? Cool. So now we have 3 devices. Let me just test that to make sure. So I'll view all devices. Here we've got my dummy light, but what we can do is I can load a configuration. And my configuration name was, whoopsies. New config. So new config.txt. And just to confirm, I'll check devices. And it looks like we only have 2, so it worked. So after loading, we get back to just our original 2 devices, so that ensures that my file IO is working correctly. And with that, I will exit, and my application is fully functional. Okay, so with that, that wraps up my video. To summarize, this project demonstrates 4 key object-oriented programming concepts. The first is inheritance, where I use smart lights and smart thermostats who inherit from the abstract device class. I used polymorphism, and I implemented that by adding a single vector of device pointers that can store and operate different device types. And for dynamic memory management, using new and delete, I cleaned up the destructor. I cleaned up memory in the destructor, so nothing crashed and I didn't have any memory leaks. And then for file I/O, I did a simple save and loading configuration for persistence that users can create basically text files or any kind of files that they want. And with that, thank you for watching.